Hi, this is Sung. I'm your online maths mentor, and we are going through permutations and combinations. We've been making our way through permutations, which is really summarized up on the board here. And in particular, we're looking at some common variations to permutation type problems or permutation type calculations, which require us to depart slightly from our formula, which we looked at, which is NPR equals to n factorial over n minus r factorial. So we looked at restrictions, we looked at with groups within groups, we looked at identical elements, right? And another common one that you'll often come across is in a circle. What do you do when you see an arrangement that needs to take place within a circle, right? So let's have a look. How many ways can you see 5 people, 5 people, let's say those 5 people are A, B, C, D, and E, around a round table. Will it be the same or different to a straight line? How or how not, right? This question just gives me the opportunity or the excuse to really show you how to approach questions that where the arrangements will be arranged in a straight line, and then to kind of show you how it will be arranged in a circle. Okay, so here we go. So in a straight line, right, where this is clearly the front and this is clearly the end, right, what you'll have is 5 factorial arrangements, 5 factorial permutations, right? Because in the first position, you can put 5 people. In the second position, you could put 4 people, 3 people, 2 people, and then 1 person's left over. You multiply those, and that gives you 5 factorial. Does that make sense? Good. So you've got 5 factorial ways of putting 5 people in a line of 5, okay, where you've got a clear front and a clear end. In a circle, you do not have a clear front or a clear end. Do you get that? So let's have a look. Ordinarily, you would basically just say the line started here. So this is your front. Hang on, hold on. So this is your front. This is your front. And this is your end here. And we're going in a clockwise direction, right? Ordinarily, what you can do is take each of the positions in the line, right? And you would have 5, 4, 3, 2, 1. Does that make sense? Cool. And then you would have exactly the same answer, 5 factorial. Does that make sense? Good. However, in a circle, right, there is no front and there is no end. It's a circle. It keeps going forever. There's no, it just basically, it's an endless loop, right? Just like probably my video tutorials feel like on a bad day. So basically, what you've got to do, right, is you've got to consider, right, that if the first position, right, started with, say, the letter A, right, you've got to consider that if every person were to move one position along, this person A would end up here, right? This person would end up here, this person would end up here, this person would end up there, this person would end up here, there. That would be considered a totally different arrangement in a straight line, but it would still be considered the same arrangement in a circle, right? It's just that you would visually see the arrangement differently. You'd see it on a slight angle. Does that make sense? And of course, if you were to move that position A there, right, that would be like moving the position from A there to A there, and then A there to A there, right? what you'll realize is that each arrangement in a circle can have 5 different arrangements in a straight line. Does that make sense? And the reason why is depending on where where your starting point is in a straight line, right? That would also be a different arrangement in a straight line if that starting point were there, or there, but it would be the same arrangement in a circle. Does that make sense? So what you've got to do is, in a circle, you've got to work it out as though it were a straight line, but then divide by 5, which ends up being 4 factorial, okay? Because 5 factorial ends up being 5 times 4 times 3 times 2 times 1 over 5. The 5's cancel out and you got 4 factorial, right? So, generally speaking, where you've got n elements or n elements in a straight line, the number of arrangements would be n factorial, whereas in a circle, it would be n minus 1 factorial. Does that make sense? Cool. Okay, good. So basically what I want you to note is that each arrangement in a circle, right, will have 5 different arrangements in a straight line, depending on where you start. Okay? So what you've got to do is you've got to divide by the number of elements in that circle. Okay? Good. Cool. And that's really what's going on there. Okay? Good. What I want to do next is look at variations within a circle, because there are variations there. Now, I want to look at alternation, groups within groups, and beads on a bracelet. Okay, good. So let's look at, so that we know that the general rule now is that there will be n minus 1 factorial arrangements, generally speaking, of n terms within a circle where there are n positions. Okay, so now let's have a look at what happens when you've got alternation happening. All right, welcome back. We are now going to look at another example, right? This time we're going to look at alternation, right? So we worked out that the general rule for seating n people around a circle where there are n positions is n minus 1 factorial, okay? So we worked that out, okay? That's the general rule. When it comes to alternation, right, things kind of get a little bit trickier, but not that much trickier, okay? So let's have a look at how we would do this. Here we've got a question: how many ways can you seat 3 boys and 3 girls in a circle where the boys and girls need to alternate in their seating, right? So you've got boys and girls that are alternating in their seating. So basically, you've got a position here for boy, 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 and then you've got positions here for girl, girl, girl. Got it? All right. Now, what we need to do is anchor, whether it's a boy or a girl, we've got to anchor one person in place, right? And fix that one person in place so that it takes into account, right, all the variations of what would happen if we rotate all the boys and the girls around the circle, okay? So, ordinarily, how many boys can fit in boy position 1? Ordinarily, it would be 3 boys in position 1, 2 boys in position 2, and 1 boy in position 1, right? But what we're going to do is we're going to anchor 1 boy into place. So even though there are 3 boys, we're going to anchor this boy into position 1. What we are then going to do is fill in the other 2 positions for the other boys in their positions respectively. So this boy, so in this position here, there are 2 other boys that can fill that position. So that's 2, and there's 1 other boy that can fill that position, which is 1. Okay. In terms of the girls now that we've anchored all the boys in place, we can fill the girls in around them in any way that we want, okay? So in other words, how many girls are there to fill that position? The answer is 3, all right? How many girls will there be to fill in the next position? Well, we've anchored one of the girls in there from the 3 choices that we've made. We've chosen one from the 3 girls that we had, so there's 2 girls left. So there's 2 choices there, and there's 1 choice there. So basically what we've got is we've got boy, 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 girl, 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 right? Or another way that you can think of it, boy, girl, boy, girl, boy, girl, right? Whereas that person there has been anchored into place, 1, and then 2 and 1, 3, 2 and 1. You multiply them together. All right, so whereas in a straight line, it would be 3 factorial times 3 factorial, the number of arrangements for boys and the number of arrangements for girls, this would be a straight line. Where you've got a circle and they alternate, you would have 2 factorial times 3 factorial. Does that make sense? And that would be in a circle. Good. So that's basically how to do questions where they alternate. You basically take one of the groups that alternate, and you anchor one person in to that first position, right? And then you work it out as though it were a straight line. Okay? Cool. Now the next type of question is basically where you've got groups within groups, right? So here you might have a question that says this, right? You've got 3 people, right? Or say for example, you've got 2 people that need to sit next to each other, right? So you've got 6 people, of which 2 are a couple and need to sit next to each other. Okay? In this situation, what you need to do is you need to consider that even though there are 6 people, these 2 people that are a couple need to be considered as though they were one person, all right, of which there will be an internal arrangement between those 2 people, seated around this round table. So there will actually be 5 people. Does that make sense? Well, there'll be 5 positions. All right. So of these 6 people, you've got 6 people of which, so you might have A, B, C, D, and then E and F are considered one person. So you've got 1, 2, 3, 4, 5 positions, and you've got to consider the internal arrangements within these 2. So it's 2 factorial, okay? So what you've got to do is consider that there are 5 people, and then multiply by the internal arrangements between E and F. So what you've got here is, because you've got 5 people, you anchor 1 in place, right? So that one's going to be 1, and then you've got, instead of 5, you've got 4, 3, 2, and 1, of which one of them is going to be a couple. Let's say this one's going to be a couple, and within that couple, you've got E and F, or you've got F and E. Does that make sense? Cool. So you've got 2 factorial. So what you actually have is 4 factorial times 2 factorial, which would be the total number of arrangements within this circle where you've got a group within a group. So you do group within a group as though it were a straight line, but then you've got to account for the fact that it is a circle, which means that you've got to take 1 off your n, your starting factorial, okay? So it ends up being 4 factorial times 2 factorial. What's that? 6 times 4, 28, 48. 48 will be your answer, okay? Good. The last thing that I really want to go through is beads on a bracelet, okay? Now, when you've got a beads on a bracelet type scenario, there is a little trick with that, okay? And this one comes up every now and again and rears its ugly head. And what I want you to notice is that with a circle, The arrangements on a circle, right? If it's a flat circle and you're looking at it from this perspective, only one perspective, then an arrangement going clockwise, right, will be a different arrangement going anti-clockwise, okay? So in other words, that's what will be the case, right? So if you've got A, B, C, D, and E, right, that's actually a different arrangement from A, B, C, D, and E. Do you see that? They're actually different arrangements to each other if you're just looking from the same perspective, right? Whereas, if you've got beads on a bracelet, if you flip that bracelet upside down, or if you were standing on the other side looking at that bracelet, what you would find is that the clockwise arrangement and the anti-clockwise arrangement will actually be the same arrangement. Yeah? It's just that what you're doing is you're seeing it as one arrangement this way, but you're actually seeing it as another arrangement from the other side, right? But what you'll find is that they're actually the same arrangement. So what you have to do in this case, where you've got a beads on a bracelet question, is you actually have to divide by 2. And the reason why you divide by 2 is you've got to collapse the clockwise and the anti-clockwise arrangements into the same arrangement, because that's essentially what they are. Okay, good. Now the arrangements in a circle one can get a little bit complicated. It has the tendency to do the heads in of a lot of students, all right? But if you can understand what's going on, they give you some of the general principles of how to attack the sort of questions that you're likely to get, the sort of variations that you're likely to get in questions for permutations where you've got arrangements happening in a circle. All right, thank you very much for watching. In the next episode, what we're going to be doing is looking at combinations. Thanks. Bye.